Okay, so I'm going to pick up right where I left off the last video, and I'm going to work on these bottom four problems right now, which are still pretty easy considering complex fractions because it's just one fraction divided by another fraction. So I'm going to continue on with my keep, change, flip, and I'm going to factor where I can. So when I look at this one, I'm going to keep, change, flip, and I see that this guy right here has a GCF that can be taken out. So as I bring it down, I'm going to bring out the 7 and leave c plus 5 over c. I'm going to change my sign now from division to multiplication, and I'm going to flip the bottom guy over. So c squared over c plus 5. And I know it's not in parentheses. I just like to put it in parentheses sometimes because I think it's easier to see those binomials that can be simplified if they're in parentheses. So I can reduce those. Remember, multiplying fractions is just like multiplying straight across the top, straight across the bottom. So it just becomes one big fraction. And so I can simplify the c plus 5 or c plus 5. Those just go to 1. This c can go with one of these, leaving me just one c. And so it looks like to me that all it leaves is a 7c in the numerator. So you don't need to put it over 1. You can just leave it as 7c. All right, when I move on to number 6, I'm going to look at what all can be factored. And I see a trinomial down here and a trinomial down here that I think are both going to need to be factored. The nice thing is both of them can be used. The shortcut method can be used because a is a 1 in both of them. So we'll be able to do that. So as I keep, change, flip, okay, I'm going to bring these down and factor. So b plus 2. And then I need two numbers that are going to multiply to 8 and add to 6. That's pretty easy, right? That's just 4 and 2. So b plus 4 and b plus 2. And then I'm going to change my sign from division to multiplication. And so when I flip this guy over, then I need to factor again. So I need to find excuse me, two numbers that multiply to negative 20 and add to negative 1. So if I want negative 20, I think I need to use negative 5 and positive 4 because I also want negative 1. So negative 5 and positive 4. All right, now I can do the fun part. I can see what common binomials I have. So it looks to me like the b plus 4s can go to a 1 and the b plus 2s can go to a 1. This is already a 1 down here. Looks like all I have left in the whole thing is the b minus 5. So b minus 5 is all I have left. And you can put it in parentheses if you want. If you don't want, that's okay too. All right. Don't let these parentheses throw you off. It's no big deal to have those parentheses there. I'm going to keep, change, flip. Now the bottom one, it doesn't look like a fraction, but remember we can always make something be a fraction by just putting it over 1. So now I have a fraction divided by another fraction. So keep, change, flip. And it looks like this has a GCF and this also has a GCF. So I'm going to be able to factor those as I bring them down. So 15 minus 15r, I can definitely take a 15 out of that, leaving me, remember, when you take out a GCF, it never eliminates a term ever. So 15 divided by 15 is 1 minus r over 15r squared times, change my division to multiplication, and then this is going to be 1 over, take out a 12, and that leaves r minus 1. Okay, now I'm ready to do some multiplication, which means I get to do some reducing because we already factored everything. The 15s definitely cancel. And r minus 1 and 1 minus r are exact opposites. How do I know that? Well, because here the 1's positive and here it's negative, and here the r is negative and here it's positive. So when they're exact opposites like that, they cancel with a negative 1. So it looks like I'm left with negative 1 in my numerator. And in my denominator, I've got 12r squared. Okay. Ooh, I got lots. It looks like some canceling to and factoring to for sure to do here. So as I keep, change, flip, this guy factors, this guy factors, this guy factors, and this guy factors. Everything's going to have something that it can do. So it looks like in the numerator first, I'm going to take a 2 out of that top one. So 2 times m squared minus m minus 20. And I bet that factors again. We'll do that here in a minute. And here we're going to take out a 3, leaving m plus 4. Okay, so I kept the top one. I just factored it as I moved it down. Change the sign, and then I'm going to flip the bottom guy over. So the 9m squared plus 36m, I think I'm going to take 9m out of that as a GCF, leaving m plus 4. And in the bottom, it looks like I can take out m squared, leaving m minus 5. So I'm almost done with everything. I just think this guy right here factors again into m minus 5 and m plus 4, because negative 5 times 4 is negative 20, and negative 5 plus 4 is negative 1. So I'm going to not look at that guy anymore. I'm just going to use the one above it because it could be factored again. All right, let's do some canceling now. All right, so m plus 4s go to a 1. And it doesn't matter which one you use. You don't use them both. It can only cancel 1 for 1, okay? So if you cancel it with this one, that's fine. You're going to leave this one alone. If you cancel it with this one, then we're still going to have this one, okay? You can only cancel 1 for 1. You can't do it twice. All right, it looks like m minus 5s. It looks like one of these m's can go with this m. And 3 and 9. So 3 divided by 3 is 1. 9 divided by 3 is 3. So if I look at what I have left in the numerator, here's a 2, 1, 1, 3. So it looks like I have a 6 for sure. 2 times 3 is 6. And this m plus 4 that I didn't have anything to cancel with, over 1 and just m. Okay. All right, so when we get on the backside now, they're going to be just a little bit harder.